In this lecture, we're talking about the scientific consensus. The consensus among most climate scientists, natural scientists, the agreement. Okay, so this lecture has 3 parts. In part A, I introduce you to the scientific method. You probably know about the scientific method, but here you learn more details. So you probably didn't know about all the principles of the scientific methods, and they're all important. Okay. Part B discusses the methodology of the Intergovernmental Panel on Climate Change, the IPCC. How does it work? Okay. How does the IPCC actually come to conclusions? And we have a look at the history of assessment reports by the IPCC. And in part C, I present the key findings of the latest IPCC report, which was just published in 2022, a relatively short time ago. So I will be discussing the current state of the climate, the scientific consensus about it. But the first thing we do is we talk about the scientific method. Okay, what is it? And it's a very important method. It's a quite special method too, the way it works. So if you look it up on the internet, you come across explanations like this one. Okay, so like you find little diagrams, and it's based on actually scientific work. So you make an observation, you think of interesting questions, you formulate hypotheses, you develop testable predictions, you gather data to test predictions, you develop general theories, you refine, alter, expand, or reject hypotheses, and it's a cycle, and you come to some result at the end. But that's actually only a small part of it. Okay, this is the scientific work. The scientific method is actually much more than this. So what is the scientific method other than this cycle here? Well, the scientific method has actually 3 key parts. One is the scientific work. Okay? The second component is the publication, okay, the reporting of findings and data, and the data archiving. Okay? The storage of data. And the third part is the error reporting. Okay? So let's have a look at these individual parts. All right. Let's start with the scientific work. Okay? Scientific work. Again, that's what we had before. Tests a new hypothesis against previous evidence. You know, it's that loop, this mechanism. But it can also just look at compiling new data sets. You know? Closing data gaps. Yeah? Developing new methods, indeed. Okay. But it can also be pure review work, you know, just reviewing previous work and you know, that's also part of scientific work. Okay. It has to be based on the best available information. Okay, using the best models, the best data sets of the highest quality. So it has to be accurate and comprehensive. It has to be transparent, and transparency is an extremely important principle of the scientific method, and therefore repeatable. Okay, so anybody else using the same data, using the same method, should come to the same conclusion. And that transparency is one of the key aspects of the scientific method. So let's have a look at the second part, the publication and data archiving. Let's have a look at that process. Okay. So first of all, it has to include a comprehensive literature review. So each publication that you look at has actually an introduction and which lists the key aspects of the most important papers published on a subject. Okay, that's an important part. Then the process itself is typically a peer review process, and it is an anonymous process. So you submit your scientific manuscript, then it's forwarded to, well, sometimes 2, sometimes up to 5, selected referees, experts in the same field of study, and they review the paper. And they might reject it based on their opinion, or they might accept it. And this is an important part too. Okay, it's important, but it's a little bit tough. It's the little bit frustrating part, because sometimes you just get rejected, your paper's rejected. You work on something for 2 or 3 years at sometimes, and you submit it, and then you get, it gets rejected, and it can be quite frustrating at times. Okay? Anyway, but what you get is, this is where you get the feedback, and that's the important part of it. You get the feedback, you get criticism. Although you might get a rejection, you just have some really often, usually helpful comments that help you to improve your work. So all methods and data have to be made publicly available. And that's, in many journals this is the case. You have to provide links to the data, or you have to publish the data themselves. If you use a computer model, you have to give people access to your computer model. Okay? Then the papers themselves, the scientific manuscripts, they should be publicly available, that anyone can get them, and that is often the tricky thing. You can't do that as a lay person. You have to pay for scientific publication. But if you go to university, they often have subscription to journals. You can get most publications. Or nowadays, journals use the open access options, where actually, and that's typically the case, that actually the authors of scientific manuscripts of papers have to actually pay a fee for the publication. It sounds confusing because you're working a long time on something, and then you even have to pay for the publication. But this is just how it is. And often it's between $2,000 and $3,000 to get a paper in open access publication. Open access publication means it will be freely available on the internet afterwards. Alrighty. So you see, it's much more. The scientific method involves all these fine details. Very, very important principles of transparency. And that is really important. So that nobody can come up with just some random suggestions like, there is no greenhouse effect. Something like that, okay? So the last part is the error report. The error reporting, the revision part of that. And we're just talking about published work. So what happens if published work contains a significant error? Again, there's a number of methods that are used, which are listed here. Okay, and I'm not going really through the methods, but it's even goes up to retraction by the authors if the results are found invalid, Okay. And that's also an important part of that. Yeah, it's an important part. But there are so many papers published nowadays, it's really hard to keep track with that error reporting and revision process. Okay? So therefore, there is a broad range of scientific journals, but some are considered more professional than others. Have a higher standing, a higher standard compared to other journals. So that's why we call some journals the top leading journals in a field, because it's about the processes and the reviewing process, the standard of that. Okay, and this is already all about the scientific method, and I hope that you learned new aspects of it. So, okay, this concludes the first part of this lecture.